so we can see. All right, so we're gonna do a little guided note sesh. See what you remember from that little video you watched. I mean, that was like a week and a half ago now. So if you don't remember much, it's not a big deal. Hopefully I will jog your memory, or if you just kind of didn't follow, help you out. But there's just some quick vocab, because these are words that I say a lot, and I just want to make sure that you do know what the heck I'm talking about when I'm saying them. So when we talk about anything that's rational, you went over this like back in the day. I do this with my freshmen in Algebra 1. Anything that's rational means it can be written as a fraction. So if we talk about rational numbers, they're just numbers that are fractions. So when we talk about rational expressions, it just means the quotient, or you're dividing, or you have a fraction, but with two polynomials. So you did polynomials back in the day as well, but just as a reminder, a polynomial can be something like this, like 3x over x squared. That's a polynomial. Or you could have something like 2x minus 4 over x minus 2. So a polynomial is just something with many terms, or it can just have one term. But we are dividing them. Okay, so that's exciting. AKA, we just have fractions, just fancy word for fraction. Our main goal is to get everything in simplest form. So that's when the numerator and denominator are polynomials that have no common divisor, no common factors other than 1. So just as a quick example, if I said something like this, x squared 7x plus 12 over x squared. Our main goal is to basically just reduce it, and we reduce when we know that something has common factors, and we know the factors by factoring it. Magical, we're bringing in what we just did last chapter. So we are basically, we're gonna be heavy on factoring. We'll try not to make any of the factoring too terrible on you, but when you see something, you're gonna factor it. So I'm gonna factor the numerator. That would be what? X minus 4, x minus 3. On the bottom is a difference of 2 squares, so that's x plus 3x minus 3. And our main goal is basically to just reduce. So if they have a common factor, we can cancel them out, because we know that x over 3 divided by x over 3 is just 1. So you can cancel out any common factors, and then whatever you're left with is your simplest form. So we're going to be doing a lot of that today. A lot of factoring, a lot of canceling like terms, and going from there. But if you can do that one, basically you can do every problem from here on out, because that's what they're all based off of. Equivalent expressions is a rational expression in any simplified form that have the same domain in order to be equivalent. So it gives you a little example. We're going to do the same thing we just did. We're going to factor. So good old factoring. Basically, when you see a problem, factor it. That's the name of the game for this. So that would be what? X minus 3, x plus 2 for the numerator. In the denominator, that would be x plus 2, x minus 1. We're going to see, are there any common factors that would cancel in the numerator denominator? And I see that x plus 2 is in the numerator and denominator. So it doesn't really matter the order. If you have them, you can cancel them. And whatever you have left is your answer. Sorry, I kind of ran out of room there, but you get the idea. But one thing we need to talk about, since we have so many fractions, is the domain. So the domain means the x values that make sense for this problem. I guess it doesn't really matter where you write it, domain. The only thing about fractions is there's one special thing about fractions that we all know, we've known it forever. It's when you have a fraction, you can't have a 0 in the denominator. You can't divide by 0, it doesn't make sense. So you have to kind of tell if there are any restrictions, aka, is there any place where these fractions, whether it's the answer or kind of going back, would have a denominator equal to 0. So it's pretty easy, it's pretty quick, you just need to be on the lookout for it. Actually, I'm going to put domain restrictions, aka, if you want to make a little note to yourself, denominator cannot equal 0. So our restrictions would be, I kind of just start with the original problem. I go back here. I look in the denominator. We have two binomials. Basically, we want to say that neither of them can equal 0. So I'm going to say x plus 2 cannot equal 0, and x minus 1 cannot equal 0. In the denominator, you just have an x minus 1 again, so you just write it once. So we would say our domain restrictions are x cannot equal, and you would just solve that, -2. And if I solve that, that would be 1. Those are your restrictions. We talk a lot more about that, but just as kind of an intro. When we have fractions, we can't have denominators equal to 0. So we go back to the factor form. So I always kind of do this one right here, because usually that includes something in there. And I just make sure that anything we have in the denominator cannot equal 0. So you can see, instead of doing them equal to 0, I said does not equal 0. And then those are your restrictions. So we'll talk a lot more about that. But once again, these are equivalent expressions. Technically, if you plug something in, you get the same answer. It's just we're trying to simplify as much as possible. Okay, so just some easing ourselves into it type deal. So we'll start with simplifying, which we've even done a few quick little examples there. And then we have some multiplying and some dividing. And then we'll just see how far we get today, and whatever we don't finish, we can do a few more examples and finish that up tomorrow. No, I'll let you know as we go. What the plan is, because I'm going to be honest, I can't even remember at this point. So I did a lot of that work before Thanksgiving, and now I need to put everything back in my brain here. Sorry. Okay, so as I start to look down, the next section says simplifying a rational expression. Okay, so simplifying basically just means we want to factor, and then we want to see what common terms are there that we can cancel out, and then whatever's left is our answer, and then we'll look for any domain restrictions, aka where the denominator cannot equal 0. Now, if you're looking at A, you're like, hey, I can't even factor that, and you're right, you can't factor it. This is just going back to reducing a fraction type deal. So that's all you're really doing for A. Marlene, are you still copying?
I just finished.
Okay, sorry, I just didn't want to rush you. Okay, so literally, when we're talking about rational expressions, we're just reducing fractions, and that's what we're doing for A. There's nothing to actually factor, so just reduce it like you would a normal fraction. If you're ever confused, back in the day, I don't know, I never know if you guys do things in 8th grade or 9th grade with the Algebra 1 stuff. But you did learn some properties of exponents, so I'll show it to you both ways, reminding you of the property, but also showing it to you just if you forget the property, how you can do it. So what I would do first is I would say, hey, I can reduce 28 over -7. That would just reduce to -4, right? Okay, that part was easy, so it's just reducing a fraction. If you can remember back in the day, your properties of exponents, the property says if you are dividing and two things have the same base, you can subtract exponents. So if I have an x to the third over x squared, if I subtract those, that would give me x to the first, or you could just write x. And I'm going to do the same thing for the y's, that would give me y to the -1st. The one thing you do have to know from back in the day as well, once again, I'll show you another way to do it in a second, you can't have negative exponents in answers. So if you ever have a negative exponent, you have to flip the side of the fraction that it's on. And you will get -4x over y. That's technically your answer. If you're like, hey, I really don't remember those properties, I'm gonna be honest, you might have even done them in 8th grade. Just think about it. So if I think about x to the third, that just means x times x times x. If I think of x squared, so all that means is those would cancel, and you have 1x left in the numerator. So you can always write it out if you need to. And for the y's, if I have y squared, and then y to the third, those would cancel, and you have a y in the denominator. So it's just how you wanna visualize it. Sometimes people like doing this to just see what cancels. Once again, that's all we're doing is reducing, and that will kind of show you where things ended up. So we always need to do one last step. It's like, okay, we got the answer, everything's simplified. We need to say if there's any domain restrictions. AKA, is there anywhere that the denominator would be equal to 0? So that's going to be a restriction. We don't want that to happen. So you can see in the answer there's a y, and I'm just looking at the denominator, there's a y. I always kind of go back to the original and start from there, and then I can kind of work my way through. So I have a -7. I can have a number in the denominator, that's fine. What I can't have is I can't have x be equal, or x not be equal to 0, right? Because 0 squared is 0, so I don't want that. And I also, I'm just gonna say this y cannot be equal to 0, because if I have a 0 there, 0 cubed is 0, you're done, doesn't make any sense. So we're basically looking at the variables in the denominator and just saying they can't equal 0. And y is already taken care of, so I'm good there, so that would be your domain restrictions. So that's something we'll kind of just get used to as we go. Oh, that's a good, sorry, I was gonna say. Okay, so the thing we noticed about A, no factoring, that's fine. We were just reducing a fraction, seeing where things ended up, and then just checking that at no points during the problem, the denominator cannot equal 0. So B, okay, this one, I can't just, once again, please don't be the person that says like, oh, I can cancel the x squared. This is a trinomial, these are all kind of stuck together. This is also a trinomial, you can't just pick one piece to cancel out. So in this case, we are going to factor this. So that would factor to be what? X plus 4, x minus 2. And then the denominator would be x minus 3, x minus 5. Excuse me, x minus 2. Where I just came up with the 5. Just be careful. I feel like that one people mess up the most. They want to do 6 and 1, but they have to be the same sign, so you just have to be careful. Our main goal is once things are factored, is there a common factor that we can reduce? And there is. The common factor is x minus 2. Okay, so whatever's left is your answer. X plus 4 over x minus 3. I'm just gonna write dr because I get lazy for domain restriction. So we're just checking, there's, at no point can the domain be equal to 0. So I had the original, I'm gonna go to the factor form of the original one, so we can see this. So basically what I'm saying is this cannot equal 0, and that cannot equal 0. It's a quick solve to do these, so you can start doing them in your head. If x minus 3 cannot equal 0, that means x cannot equal 3, right? Because I would solve that, I would add 3 to both sides. And if x minus 2 cannot equal 0, that means it also cannot equal 2. So once again, I'm saying, excuse me, what am I saying? I'm saying x minus 3 cannot equal 0, and then you just solve it like a normal equation. And then x minus 2 cannot equal 0. And once again, I solve it, that's what I'm getting 2 from. And then once again, that's the same factor, so I don't need to do anything twice. But you need those domain restrictions there. You can't have fractions with a 0 in the denominator. All right, let me do C. And then, I forgot what it was. C, let's factor it, because nothing is really happening right now. So I noticed in the numerator there's a GCF, right? So I'm gonna factor this. Remember, GCF is still factoring. So there's a GCF of 4, and I would be left with 3 minus x. The denominator is a good old difference of 2 squares, x plus 3, x minus 3. I'm starting to say, okay, I'm looking for a common factor, I want to cancel it. These are not common factors, right? This is 3 minus x, that says x minus 3. They need to be the same exact thing to cancel it. So what I do here, I don't like it when it's in this order, yeah. So I'm just gonna write it as 4, I'm gonna write it as negative x plus 3. Because once it's in the same order, I notice, well, I don't want a negative right there. So what I'm gonna do is divide a negative out of this, divide by -1, just to kind of fix my signs. And that would give me -4 times x minus 3. That's looking better. So sometimes you might just have to kind of maybe rearrange stuff. You notice that they have things in common, but they're not exactly the same. So I always like to put things in the same order. And then if you notice just that a sign is off, you can always divide out of -1, why not? And once I've done that, cancel, cancel. I have a common factor. I'm left with -4 over x plus 3. Perfectly fine answer, beautiful. And then I need to list any domain restrictions. I'm just gonna write dr again because I get lazy. So I kind of go to the factor, that first denominator there, and then if anything kind of moves around, we can deal with it. So we're saying, once again, that this cannot equal 0, and that this cannot equal 0. And then you just kind of solve them. So my x cannot be -3 or +3. Besides that, it can be anything. So I'll do that up for a second. Main goal, reduce as much as you can. Excuse me. We might have to do a little factoring in the process to see what the common factors are. And then once you have everything like all settled and canceled and reduced, just make sure you list your domain restrictions, which is where the denominator cannot equal 0. Okay, let's look at a little multiplying. So let's try, we'll kind of figure out A and B, and then we'll take a little break ski. You guys can decide what to go in the rain or not. I think I left out my raincoat today, so I'm good. Okay, multiplying is like super similar to just simplifying, so I kind of like it. There's not really anything too fancy or exciting going on. Our main goal is to just factor things if you can, and then to just cancel out common factors. We can't factor anything today, so we're just saying, what can we reduce, simplify? You can kind of, because we know hopefully in multiplication, order doesn't matter. You can kind of flip things around. You're basically just multiplying the numerators and denominators, so we can cancel however we please. So I just start here, and I say, from this, is there any common factor anywhere in the denominator? Ooh. 3 and 12 are both divisible by 3, right? So I'm just going to start reducing where I can. If I divide that by 3, and divide that by 3, this ends up being 1, and this ends up being 4. I have x squared, and then the only other x I see is right here, x to the 3rd. So I'm going to reduce it. When I reduce it, you can either subtract your exponents, or you can think about it as x times x here, and then x times x times x here. You'd be left with just an x in the denominator, and that would cancel. 7 over 5, I can do a big nothing to, right? Those don't, so I can't really touch those. And then y over y would just cancel. Okay, so now I just have a lot of stuff going on, so I'm gonna organize my brain. So this ended up just being 1. That ended up being 5. Over here is 7, and then 4x. So I'm just gonna multiply straight across, and I would get 7 over 20x. So you're really just like reducing wherever you can, as long as it's in a numerator and denominator, it doesn't matter the order. So you're just kind of seeing what works. We do need to list our domain restrictions. Go back to the original problem. I always kind of go back to the original to do it. So just look at what variables are there. I had a y. That can't equal 0, because if it equals 0, the denominator is 0, it's a big mess. So y cannot equal 0. And then over here I have an x. Once again, if that was 0, the whole denominator would be 0. And then that's it. So those ones, if you really wanted to, you could kind of make this one big thing and say, oh, this is 21 x squared y, and then this is 60 x cubed y. And you can do it from there if that makes you happier to do it as a kind of one thing and reduce it. But in the end, it doesn't really matter. As long as you're reducing at some point, we should get the same answer. All right, let's try B, then we'll kind of stop, see if there's any issues, take a little break, and then maybe we'll do a division problem or two, but we can leave other stuff for tomorrow as well. So B isn't like A. B isn't like I can just like start canceling things off. No, I'm gonna have to do a little bit of factoring before I move on. You're gonna see a lot of factoring. Remember GCF is factoring, so that first one I'm just gonna take out 3. Right? That denominator is a difference of 2 squares, so we always recognize that. It pops up a lot. We've already seen it a few times, just with the problems we've done. And then over here, what do we got? So the numbers aren't terrible, so hopefully that makes it a little bit better. So that would be what, x plus 2x plus 3. And that would be x plus 3, x minus 1. I'll stop for a second, just to give you a second to run down. Literally all we do is look, is there any common factor? It doesn't matter what fraction it's in. If it's in a numerator, denominator, it cancels. So I just kind of go through. We have a 3 here. There's no even numbers to cancel it, so that's just gonna have to stay. We have an x minus 2 here and an x minus 2 here. That reduces to 1, right? Anything divided by itself is just 1. We have an x plus 2 here, and even though it's over here in this thing, they still cancel. So the x plus 2's cancel. We have an x plus 3 here and an x plus 3 here. I don't know what. Like, as a math teacher, that's just like very satisfying to start canceling things out. And then whatever's left is your answer. In the numerator, all you got left is 3. In the denominator, you have x minus 1. So the last thing we need to do is label domain restrictions. Don't just do it from the answer. You have to, I always kind of do it from when I factor that problem. So I just go through each binomial in this case and say they cannot equal 0, and I see what x cannot equal. So x cannot equal, if that's not equal to 0, that would be negative 2. This would be positive 2. This would be negative 3. If you notice, I'm just finding the opposite sign because you would just do that, and that would be 1. So that has 4 domain restrictions because you had 4 binomials in those denominators. Okay. So we looked at rationalizing, we looked at that. You did some of this before your little break, but I can't even remember what I did like this morning at this point, so I like to re-go over that stuff. So we see some dividing. Well, if we have time, we'll do 1 or 2 of those, and we see a few more multiplying and dividing as we go. So we'll do a little bit more practice, make sure we're feeling good. Go from there. But let's take our little mask break. Do you guys, it does look like it's raining. Would you like to go outside or we just stay in there? I have my raincoat, so it doesn't matter to me. Oh my God.
Is it raining?
I just saw people out there and it looks like it was raining on them. I know, I can't really tell, but I think it is.
You know what? I'm fine to stay inside and
Okay.
fine.
Yeah, no problem, whatever. So just, just if you need to spread out for a second, go for it. But I'll give you a few minutes, like take a break. This is a good just rain break too. You can chat, you can take your phone out, you can get up and walk around and move your legs, you can go to the bathroom. I don't know, do something for you. Okay? But I'll give you a few just to relax. Once again, if you're taking off your mask, that's the point of this. Just make sure you're a little spread out. Yeah.
Thanks.
Absolutely. Maybe you can just like a little walk up and down the hall, go for it. But I'll give you like 5 minutes and then we'll come back together. I wanted to tell you about the clubs, just in case you haven't heard about them yet. And maybe we'll just do one or two wrap-up problems. No. Why? Did my Screencastify not work? This is very, oh no, it didn't work. Nice thing about simplifying, multiplying, and dividing, they're all kind of the same thing. So it's not like we're like adding crazy new steps. For dividing, you are just multiplied by the reciprocal. For multiplying, you're just kind of canceling, and for simplifying, you're just canceling. So that's nice. So we'll look at some other examples tomorrow, so just bring that back. There's a few more on there, and we might add a few. Just to let you know, our next section after multiplying and dividing, which we'll do next week, is adding and subtracting. It's not necessarily as like nice, beautiful, easy. So what we decided was like before we do the harder stuff, because you have to do common denominators with polynomials, it's kind of a pain. We wanted to give you just like a little assessment just so we could get a grade in before the harder stuff. So you are going to be having like a little Edge Elastic quiz on Friday. So just if you're seeing something you're not comfortable with, I'm after school Tuesdays and Thursdays. Feel free to stay or just always ask in class or email me or do whatever because I can help you. But if you're seeing something you're not getting, I just wanted to give you a heads up on that. But once again, we would rather do that than like pile on a bunch of stuff and then they get a little bit more confusing and then it's just a big old mess. So that's the plan. Let me know if you need help with anything, but once again, tomorrow we're just doing more practice / examples with simplifying, multiplying, and dividing. So always ask tomorrow. So that's that.